everyone. Welcome back to the series. As discussed, we are continuing with this D.E.Shaw interview experience today. We already discussed the first question in one of the previous video and all its possible follow-ups. The follow-ups were quite interesting in this problem, so I would recommend you can watch that as well. I will link them in the description below. In this video, let's discuss the rest of the questions of this interview experience. So the next question was searching in a rotated sorted array. So this is very standard question. You can find a lot of articles regarding this question, and uh, there are a lot of YouTube videos as well suggesting how to do that. You can go through them, and if you still want me to create a video, I will go through them. I will create the video as well. The reason I'm not creating the video is this question doesn't have of the follow-ups, like a good follow-up as well. So it the interviewer also asked the standard version of the problem only. So for now, let's go ahead with the third problem of the experience. We are given a vector of strings and a string. We need to find if the string can be formed using the words. So let's try to understand the question. So we are given a vector of words and a string, and we need to find if a string can be formed using the words. So basically, this, let's say this is the vector of words, and this is the string that we have. Now we need to just say whether we can form this string using the given set of words or not. So that's the question. Now in this situation we can form it. Basically this is one of the string, then this is the second string, and this is dog is the third string. So basically these three, if we just combine these three, uh, we can see that we can form this given string as well. So the answer for that would be true. So that's what the question is. So again, before moving forward, I would encourage you to pause the video and think of any ambiguity in the statement if you can. So just to give you a hint, there is a very crucial ambiguity in the question. You can pause the video and think about it for a minute. So let's discuss the ambiguity. So the ambiguity is, can we use the same word multiple times? The question doesn't clarify that if we can use the same word multiple times or not. So the solution will change drastically based on the answer of this question. So we will see how solution will change. So first, let's assume the answer for this question is yes, uh, we can use the same word multiple times. So now let's understand if the if we can use multiple times the same word, then how does the solution looks like? So now just for so let's try to understand with the same example. So let's take the same example, cats and dogs. So uh, basically this is the uh, string that we have to form. Now uh, just think of it as in a very naive approach. We have been given a set of strings already, and we need to form this particular string from this given set of strings. So what could you do? Like basically you have to form, like you have to take the last string somehow, right? So basically when you form this string from the given set of words, the last set of words, like you have to take the last few characters, and that will correspond to one of the words in the given set, right? So let's say you, like what are the possible scenarios? Let's try all possible scenarios. So let's say we take this character only. So if this is a word in this dictionary, then we can say our answer just depends on whether this can be formed or not. So basically we have reduced the problem to the same problem. So the previously the problem was whether this entire string can be formed with this given dictionary or not. Now the problem becomes like when we have separated this and we are saying that this is already present in the dictionary. Now the problem becomes whether this particular piece can be formed from the given set of words or not. So like this is kind of the same question but with limited constant. So that's why, like, that's how we reduce the problem. So basically you can see a clear cut recursion here. So if the word is present, we will just reduce the problem to a smaller set. So let's assume the word is not present. So let's say that the g is not present in this character set. Then we will try og and see if og is present or not. If og is also not present, we will try dog. We'll see if dog is present in this set of words or not. If dog is also not present, then we will try ndog, and if it is like see if it's present or not. Let's assume that it is present. So if it is present, then we will see uh, whether this particular set of characters can be formed using this string or not. So basically, we have reduced our problem. Uh, we have reduced the string size of our problem to a smaller size, and now we are solving the same problem. So hope you can see the recursion here. So the recursion, let's write the recursion formally. So let's say the function takes in index that denotes the ending position of the string that we are handling. So basically, previously we have been handling this. So so on starting, we have been handling this part, like we this entire piece, right? Now this entire, like the in this case the index will be the last piece. Similarly, now when we reduce, let's say the dog is present in the set, so we reduce the problem to this particular string. In that case, the index will be this position. So the index denotes the last position that we care about. So now this index, like we will just traverse over all the strings, basically all the prefix or all the suffix. Basically we will traverse over all the suffix, and if it is present in the dictionary, then we will just see if f of j, let's say the suffix is ending at j, like starting at j, then we will see that if f of j minus 1, whether f of j minus 1 is true or not. If it is possible to form, basically we have separated this dog. Now we are saying if it is possible to form this CATSAN or not. If it is possible, then the answer for this f of index will also be true. Otherwise, the answer for this will be false. Now, with this recursion, we will just memorize the recursion and we will have the solution. So, what is the time complexity of this approach? Is like we have total n index, like the length of the string, let's say, is n. So we have total n calls to our f function at most, and in each call we are traversing over every suffix. So every suffix, like basically will take order n time to traverse, and in each part we are seeing whether this, let's say we take this dog suffix, so we are seeing that whether this dog suffix is present in the dictionary or not. So the lookup type can be order 1, but lookup time basically denotes on the size of the string that we are looking for. So if you have to, let's say you have two string s1 and s2 and you have to compare them for equality, you have to traverse s1 and s2 completely to basically say if they're equal or not. So that's where, like, the average string size. So that is the overall time complexity of this approach. Now let's just look at the pseudocode quickly. Uh, so the pseudocode looks something like this. It's exactly similar to what we discussed. So if, like, for this function which takes in an index of the ending position, we check for each possible starting point 0 to index. So if we are at this index, we will check all the positions. Like let's say if we are at a, we will check a, we will check sa, we will check tsa, we will check atsa, and so on. So basically we will check every every starting position to index, we will check this. Now the current string is from starting position to index. So let's say the starting position is here, so the current string is atsa. in our case. So if this is present in the dictionary or not. If it is present in the dictionary, then we will check whether is possible of this should be index minus 1. So this is not index, it should be index minus 1. So if the remaining string can be formed or not, like if it can be, if it is true or not. If it is true, we will return true. Otherwise we will continue until we exhaust every possible suffix. If none of the suffix if for none of the suffix this condition satisfies, then we will just return false from this entire function. So hope the approach is clear. So let's look at the sample implementation for this. So the sample implementation, like there's a lead code problem of similar type. I will link the link the question in the description below for you to practice as well. So this is basically the same question. So implementation looks something like, so we have prepared a map like set of all the string so that our lookup time is very like uh, we can look up this any string in the dictionary very fast. So we are saying that if there is nothing in the string, then it is possible to make this string. Otherwise, uh, we will first say that it is not possible to make this string, and then we will look at every possible starting index. For every possible starting index, we will make the last string. So basically, uh, let's say like this is the index and this is the starting position. So we will make the last string. Last string is dog. So we will make this last string and check whether the last string is present in the dictionary or not. If it is not present in the dictionary, we will just continue and try another suffix. If it is there, then we will check whether it is possible to form the remaining string or not. So we're just calling the same function with start minus 1. And if this is also possible, then we will just mark answer equals to possible and just break from this entire loop and return the answer. Otherwise, if we have exhausted all the suffix and none of this is true, we have already marked this as not possible, so that will be returned from here. So hope the solution is clear. Now, if you remember, we have asked one question to the interviewer, right? So we have asked that it is whether we can whether it is allowed to use the same word multiple times or not. So the answer for that was yes. So that the solution that we just discussed will only apply when the answer is yes. Because let's say there is a string, uh, let's say this a b b or a b a. Now there are like the dictionary that we have contains three strings, so a and b. So now the answer for this will be yes, because we can use a twice and there is b as well. So if you remember, we are not changing the dictionary anytime. So when we take this suffix, we will again say that whether a b is possible with same set of words or not. We are not removing a after taking a, right? So that's where the previous solution was. But now, if let's say the answer for this question is no, like we can't use the same word multiple times, then our solution will change drastically. So basically, uh, let's just clear some of the spaces here. So now let's say we again have this same cats and dogs, or let's take this example now. This AAB, AAB, BA, AABA, and the string is AAB. So once we have taken something, we have to remove this from our dictionary set. So whatever function we have written like f of index, that is correct. Only thing is this needs to be aware of the dictionary as well. So previously our dictionary was constant, we are not changing the dictionary anyway. So now dictionary itself is not constant. Whenever we are taking something from the dictionary, we'll just remove it from the dictionary and then pass the new dictionary to the next like when we are finding the whether it is possible to form the next set of strings or not. So basically, let's say we take the dog suffix, so we will remove the dog suffix from this string, and then for the remaining string we will call the remaining, like we will call this function for the remaining string, but we will also pass an updated dictionary here. Okay, so that's the solution basically. Like we if we do this do the same thing and do memorization for this will work. But now if we are changing dictionary, like we have the second state is the entire dictionary, let's say, then we can't store dictionary in a array, right? Because if you look at the solution, our dp state was containing index. Now let's say this dictionary is also changing every time we do something, then we have to have another dimension that will be like our new dictionary, right? So this if this will be an unordered set or an unordered map, then like the this next dimension, making this next dimension will be difficult, right? So that's where instead of passing a new dictionary, what we will do, we will pass in let's say used mask. So what does use mask denote? So uh, let's say this is the set of strings that we have. So after, let's say we choose the dog, initially used mask is 0, we haven't used anything from the string. Now when we have chosen dog, so we have to remove this dog from this list, right? So what we will do is we will say that uh, second like second word from the dictionary is chosen already. So we will update this remove marked with uh, 1, like 2 raised to the power 2. Why 2 raised to the power 2? Because like basically we have 1 2 3 4 5 6 words. So for 6 words we need 6 bits, right? 1 2 3 4 5 6. Initially everyone is 0 because we haven't chosen any one of them. So these are the 6 bits. Initially every one of them is 0. Now as soon as we choose dog, we will update this bit to 1 because we have chosen this second one, right? So we will, instead of passing it as a list of zeros and ones, we will just convert this entire thing to a binary, to its decimal form. So this is the binary. You can treat this entire thing as a binary, and you can convert this to a decimal form. Decimal form for this would be so basically this is a binary and you have to convert it to decimal form. So decimal form for this would be 1 2 4 8 16. So for this would be 16. So basically we are representing this entire vector with the corresponding number, and this number will pass to the function. Basically this the mask, the used mask that we have talked about, this used mask will be updated to 16, and this 16 denotes exactly this particular sequence. Now for like let's move forward. Let's say we have also taken san. So if we have taken san, we have to remove this as well, while continuing to query for cat, like this t character. Then we have removed this san, so we will update this to 1. Now when we update this to 1, corresponding binary represent like corresponding decimal representation of this would be 17. So we will just like pass 17 as a used mask in our while calling this function. So basically previously we are using start minus 1 only. Now we will also call this function with new used mask. So new used mask will contain all the numbers which are set in this used mask plus the number which we have currently chosen. So hope the approach is clear. Like let's look at the pseudo code for this as well. Uh, so this is the pseudo code. Like uh, as discussed, we have taken now two of the parameters. One is index, like previous, like the last index that we have to form until, and the second one is mask. So mask denotes this exactly the same thing that we have just discussed, like this entire stuff. Uh, whatever we have used, we will just mark it as 1 and pass the corresponding decimal representation to be stored as a second dimension of the DP array. Now, again, this part is very similar for each possible string. Like we will start with each starting position, and we will then check whether current string is in dictionary or not, and whether that is not masked, like that is present in the masked or not. So basically, once we have the mask, we can then convert it back to our like ones and zeros, right? So let's say we convert it to our ones and zeros. Now, when we see that the current string is in dictionary, then we can again check whether that particular position is in the mask or not. If that particular position in the mask, we will continue with the next set of string, because that particular string from the dictionary is already taken in the previous iterations, so we can't use it again. So that's where we will move forward. And if it is not present, let's say we ended up choosing this particular word from the dictionary, then we will update it to 1, and then call this function with again, this would be index minus 1. Call this function with index minus 1 comma all the bits that are set in mask plus this jth bit. So I am denoting this with j. So this jth bit will be now 1, and we will call the same function again. So basically what we are saying is whether it is possible to make the remaining string with all these particular dictionary words used or not. If it is possible, return true. Otherwise, we will follow the same set of steps. And if we have exhausted all the suffix, we will return false from the function. So that's the solution. So I would encourage you to implement this yourself. If you find, like, if you want me to review your code of this implementation, please post them in the comment section below. I will review it. And I hope you understand the importance of asking right questions the right time. So if you haven't asked, like let's say if you haven't asked this question, and interviewer has no in his mind or her mind, then you would have wasted your entire time solving this question using like only single or like only this particular part. But you can see just a yes or no change the problem quite aggressively. So previously the solution doesn't include this mask at all, but now we have this mask as well. So what will be the new time complexity of the solution? So whatever was the previous time complexity, so let's say previous time complexity was x. So whatever was the previous time complexity, it will be multiplied with 2 to the power of number of words in the dictionary, because this mask will contain like how many, like let's say there are d words in the dictionary. So everything will have two possible values, either 0 or 1, right? So 2 into 2 into 2 into 2 into 2, so that will bring us to 2 to the power d. So that is the total time complexity of this solution. So if you have any doubts regarding the question, please post them in the comment section below. And I think that's all for this interview experience. We will meet again with new interview experience tomorrow. Thank you.